Good evening, Adrit. 4 पे Hamza. Please put on your cameras, unmute yourself. Very good evening to all.
Good evening, ma'am.
Good evening, ma'am.
Good evening, everyone.
Good evening.
Good evening. So, Shivam, how was your exam? The 30 mark subjective test. Why don't you put on your cameras, everyone? Quickly do it. Come on the screens, everyone.
Ma'am, my camera is not working.
Please get it rectified.
Good evening, ma'am.
Good evening.
Ma'am, I'll on my camera in 10 minutes. That's fine.
Shravani,
Good
Hamza,
evening,
Jai.
ma'am.
Good evening. Come on the screens, everyone, quickly.
Ma'am, I'm in a place like where I cannot on my camera.
How was the test? How was your test?
Ma'am, it was nice.
Yeah,
Good
Ma'am, it was good.
great, great. I hope all the students have attempted the complete test and didn't left
Yes.
anything.
Ma'am, I couldn't do the test because in my region there was so much rain. It was continuous for 2 hours.
Because,
There was so much heavy rain and it continued for 2 hours.
okay, fine. So I thought let us give a summary to the same chapter once today, okay, where we all will have the interaction. Means not only I will put up question, but you people will put up questions to your classmates, your batchmates. Fine. So, uh, mm, Soumya,
Yes, ma'am.
Soumya,
Yes, ma'am.
yeah. You have to summarize the topic of a reflection of light and plane and regular and irregular reflection.
Okay, ma'am.
See, don't hesitate. Whatever you people know, when you will speak up, you'll develop more confidence. When other students will, cross question you, then you will like it. You are finishing yourself. Right? So do not hesitate and come up with your words. Soumya,
Ma'am, but what do I have to summarize on again?
speak little louder. Is she audible to all? Is Soumya audible to all?
Yes, ma'am.
Okay.
Ma'am, I asked what am I supposed to summarize on?
Pardon?
Ma'am, I asked what am I supposed to summarize on?
The reflection of light, this particular phenomena reflection, and regular and diffuse reflection, mean regular and irregular reflection. If you want, I can share the worksheet also. Sorry, the notes also.
Or do I have to summarize on it now?
Hmm?
Do I have to summarize on it right now?
Yeah, summarize in your own words.
Okay, ma'am. Give me a second, ma'am.
Okay, raise your hands, because this way we do not have time to waste, children. I'm continuously telling you, do not hesitate, come up with your words. Your doubts will become more clear. It's okay. If you make mistake, that's absolutely fine. Who is ready to summarize? Raise your hands quickly. And who can speak louder as well? Adrit,
Yes, ma'am.
Ma'am, can you repeat the question once?
dear, please listen carefully, everyone. You have to summarize the reflection of light and regular and diffuse reflection. Raise your hands.
Ma'am, can I?
Siddhan, no. Who else? Ashwat? Mm. Divesh? It's really strange, you know, that nobody else except Siddhant is coming up.
Ma'am, I have a doubt in the test.
Okay, we'll be discussing test later.
Okay.
Charvik, Divesh, Ashwat, Aishwarya. Okay, Siddhant, you do.
Ma'am, can I do?
Siddhant, yeah. Who, Divesh, you were asking me?
Yes, ma'am. That time my mouse was not working.
Okay, yes, Divesh, please.
Ma'am, it's like regular reflection is when like the light
Wait,
falls
wait,
on a
wait.
smooth
Just a
surface.
second, just a second. Now, if Divesh is speaking, everybody else is supposed to mute the mic. No noise should be in the class. Continue, Divesh.
Ma'am, it's like regular reflection is when the light falls on a smooth surface or a still surface where the parallel light rays again reflected back on parallel. Means like the example a mirror or a still water and
Example is mirror,
a still water,
dusty water. Okay,
still.
the dusty water reflects the light well.
Ma'am, I said still water.
Still water. Okay, sorry. So sorry to hear. Still water. Okay.
Diffuse reflection is when like it falls on a rough surface, and the parallel right rays will not go parallel again. They go on opposite sides like that.
We cannot say opposite sides, but in random direction because of the irregular surface.
Okay, ma'am.
Great example for irregular reflection.
Like stones and some metals which are not polished.
Okay. Any wooden material in our home, the fabrics like the curtain, bed sheet, the clothes we are wearing,
Yes,
or
ma'am.
there are many examples. Okay. Who will tell the laws of reflection? Children, just raise your hand and come up. If by mistake or
Ma'am,
no,
can you
if
repeat?
you tell anything wrong, That's fine. Who do not make mistake? Everyone can make mistake. Even
Ma'am,
I
can
can make
you,
mistake.
ma'am, can you repeat?
Laws of reflection. Yeah, who else? Soumya.
Yes, ma'am. Can I explain reflection of light? Reflection.
Hmm?
Reflection of light, when a ray of like light approaches a very smooth and polished surface, the light ray bounces back. This is known as reflection of light. The the incident light ray that land on the surface is reflected of the surface. The ray that bounces back is called the reflected ray.
Okay, what are the laws of reflection which is followed every time and at any surface? One of the law is very important.
And can I?
It is about no. It is about angles, Soumya. It is about the angles.
Yes, ma'am. The law of refraction states that the incident
The angle of
ray, the
incidence
light,
is what? Is how connected to angle of reflection.
it's like it's like, and the normal of the surface of the mirror is this lie in the same plane.
They lie in the same plane. How angle of incidence and angle of reflection are connected.
Ma'am, the angle of reflection or angle of corrected is equal to the angle of incidence.
Speak loudly and speak again.
Ma'am, the angle of reflection is equal to the angle of incidence.
Incidence, very good. And with the ray means angle of incidence is measured with the surface at which the light is incident or with the normal at which the light is incident.
Normal.
With the normal, with a perpendicular line which we draw perpendicular to the surface where the light is incident. Great. Next, okay, down your hands. Divesh is insomnia have their turns. Now, luminous and illuminated objects. Rest of you, I want to give the chance to everyone today. Advika, great.
Ma'am,
Hmm.
repeat the question.
Luminous and illuminated objects. Tell us anything you know about it.
Ma'am, luminous objects are objects that emit light, example stars, sun, etc. And non-luminous objects are objects which do not emit light, like example scale, paper, book.
Okay. I want more examples for each of these. More examples.
Ma'am, luminous objects, sun, light bulb, sun, and non-luminous curtain.
Ma'am, torch.
Ma'am, firefly.
Which light?
Ma'am,
Ma'am,
torch.
firefly.
Great. Correct.
Ma'am, a candle.
Candle, very good.
Ma'am, torch. Ma'am, bonfire.
Uh, I missed that some of you spoke up. I don't know, Adrit or Ashwit, somebody.
Ma'am, bonfire.
Very good. Great. And for illuminated objects?
Stones,
Ma'am,
clothes, book,
Ma'am, moon.
Hmm.
moon.
Okay. Fine. And everything in our room except the tube light, the LED bulb, except these, all other things are illuminated objects only. Fine. Now tell me about the plane mirror, the characteristics of image obtained by a plane mirror. For this, who will be there?
Ma'am, can you repeat the quiz.
Next topic to summarize is characteristics of image obtained by a plane mirror. Aishwarya, come. Yes, Aishwarya.
Yes, ma'am. It is formed by diverging of light rays. It is small, erect, and virtual.
Small, erect, and virtual means if my height is 5 feet, in the mirror I'll appear 4 feet.
Ma'am, it is also right or inverted.
Oh, sorry, upright. It's upright,
Hmm.
uh, virtual,
Very good.
and like bigger in size, I guess.
Means you have told virtual, erect, and what about the size?
Big, like
Hmm?
small, ma'am.
Dear, the plane mirror we all have in our home, and we look into the mirror with
Ma'am,
the
can I answer?
Same size.
same size, yeah. And what about the distance we are standing from mirror? What about the distance we are standing from mirror?
And can I?
Yep, okay.
I'm like the distance, like the distance of object from the mirror will be same as the distance of image from the mirror, and the image will be laterally inverted.
Laterally inverted. Okay. Adit, you want to say something?
Ma'am, actually, those were the points I wanted to tell.
Okay. You can repeat it, that's fine.
Ma'am, like the image is virtual,
Hmm.
and it is the same size when you stand. When the distance is small or big, it is laterally inverted,
Okay.
and it is erect.
Okay. Adit, what do you mean by virtual image? How will you explain this word virtual image to a person who knows nothing about light?
Ma'am, like
Give me some hint, any word by which you want to explain. I'll help you out. Anyone else? How will you explain the concept of real and
Ma'am,
virtual image?
like basically, real images are obtained using a converging lens or something
Siddhant,
like
wait.
that.
Siddhant, wait.
Ma'am, like a virtual image means the light rays meet apparently within the mirror.
Hmm.
So that is when a virtual image is formed, and a virtual image is always erect,
Okay. Yeah, correct.
upright.
Ma'am, can I tell?
Okay, please say, Divish.
Ma'am, like in the virtual image, means like it's the apparent meeting of light rays, and they do not require a screen.
Hmm.
And in the real images, that's the actual meeting of light rays, and they require a screen.
Yeah, correct.
Ma'am, the examples of virtual image are plane mirror,
Hmm.
convex mirror, and concave.
Concave, yes, in single case, concave also. So very true. Ajit, you also listen. When if you look at the diagram, I have drawn on the screen for the plane mirror image formation. The light rays, on the left side, light rays were reflecting, but they were diverging. So if the rays are diverging, how can they meet? And how means no intersection point means no point of image, no scope at all, right? So what we did on the right hand side, because if the light rays are diverging on the left, definitely they will meet on the left right side if we produce them back. So we are producing them back, it means that we are producing on the paper, but such phenomena is actually occurring inside the mirror. Okay, we have produced it, suppose 5 meters away, but the mirror is not 5 meters thick. So everything is happening in that so thin piece of mirror. So slim mirror means all such is happening apparently inside the mirror. That's why we say virtual. Something which is not true, something which is pseudo, which is false. Okay. So we used to produce them on the back side of mirror, which is actually not so thick, which do not have so much distance behind the mirror. That's why it is called virtual image. And obviously, if it is happening inside the mirror, if the image is visible to us by just standing in front of mirror, we say it virtual. No screen is required for that. Okay, this means virtual image. And virtual image is always erect. Means if my head is up, my legs are down. Same way for the image. Why we are telling this? Just a second. Because in some spherical lens, like in concave lens, many a times image obtained is inverted, vertically inverted. If I'm standing head up, legs down, my image will be head down and legs up. That way. Okay, so plane mirror always form virtual and erect, means same side is up. And yes, you already told laterally inverted. Any doubt in this? Anyone?
No, ma'am.
Adrit, any doubt now?
Yes, ma'am.
Adrit, any doubt?
No, ma'am.
Okay. Next topic comes spherical mirrors. Yes, so someone please introduce spherical mirrors. I want to hear from Charvik. Who else is left? Sriyansh and Ashwath. The students who did not have any chance, please come up.
Ma'am, spherical mirrors are two types, which are concave and convex mirror. Concave mirror is also known as converging mirror, and convex mirror is also known as diverging mirror.
Very good. But why they are named so?
In a concave mirror, when the parallel beam of light hits the they will meet at the same point, which is known as focus.
Plus focus, no, not plus focus, which is known as principal focus.
Okay, principal focus. In diverging mirror, the parallel rays of light will diverge each other. That's why it is known as diverging mirror.
Ashwat, you got muted, in between some part. So can you repeat for diverging mirror, why it is known diverging?
Ma'am, the parallel beam of light will diverge. That's why it is known as a diverging mirror.
Okay. So where the image is obtained, or is there any, focus point in the convex mirror also? Is there any focus point in the convex mirror as well?
Ma'am, it forms like back of the mirror.
It forms in the back side of mirror. Means in concave mirror, we will require a screen on the same side of mirrored surface. Okay. Whereas in convex mirror, we will see the image in the mirror only, like we see in the plane mirror. The difference is just this: the convex mirror will form smaller images because actually it is diverging the rays. So that all the wider view of diverging rays is gonna uh, confine in that small piece of mirror. So we will have very small images obtained in that smaller piece of mirror. Means we will be having a wider view, smaller images with a large view. Fine. Next, image characteristics of image obtained by concave mirror. Charvik, Hamza, Rohini, Advika. Characteristics of image obtained by concave mirror. What is the nature of image?
Ma'am, like when the object is close to the concave mirror, its image is erect and comparatively larger than the size of the object. And when the object is moved away from the concave mirror, the image in the mirror becomes inverted and it becomes comparatively smaller than the size of the object.
When the object is far away, yeah, or you can say, at focus or beyond focus, the size is smaller.
No, no, like I'm saying that when the object is moved away from the concave mirror, its image, its image in the mirror becomes inverted and it becomes smaller than the size of the object.
Let me tell you, although, this is at the level of class 10, I told you a few of the things so that you can have idea. So let me tell you, there are, varying size of images obtained by concave mirror. You just remember this, all of you, that when our object is at infinity, or if we are bringing it close to the mirror till the point of focus, the image will always be real and inverted. Means it will require a screen to form image and it will be upside down with the size not necessarily smaller than the object in all the cases. It will be, sometimes it will be bigger, sometimes it will be smaller, and in single case, it will be of same size as well. Okay, so it will be of varying sizes. But in the last case, when we keep our object between the focus and the pole point, means very close to mirror, that is a special case when object will be virtual. Virtual means the image will be seen in the mirror itself. In the mirror only, no screen will be required in that case. And the image will be enlarged. And this case particularly is, made use by the doctors, by
Yes,
the dentist, by ENT, by ophthalmologist, etc. Or
ma'am,
about
solar cookers.
at home, we can use it for shaving mirror, for
Ma'am,
mirrors to have
solar
a wider
cookers.
view of our face.
Mom, headlights of vehicles and searchlight.
Yes, correct. Great. Now, convex mirror and its uses. Nature of image by convex mirror and its uses. Come, Sriyansh. Wait, Ashwarya, wait. Sriyansh.
Yes, ma'am.
Yeah. Characteristics of image by convex mirror and uses.
Okay. Convex mirrors form a virtual or a erect mirror which is smaller than an object or it is diminished.
Okay. The image by convex mirror are always diminished.
Diminished and smaller than the object.
That same thing. What about real and virtual?
It forms a virtual image.
For all the cases wherever we keep the object.
Yes.
Okay. Inverted or erect?
It is a erect image.
Always erect?
Yes.
Yeah. So that's simple. For convex mirror, for diverging mirror, no exceptional case, always the image will be virtual, erect and smaller in size. And that's why the mirrors are used as
Rear view mirrors in cars.
rear view mirror. Yeah. Rear view mirror in vehicles. And, for having the larger view in public
Lamps.
spaces at railway station, metro station, shopping mall.
Street lamps.
Shopkeepers also install these mirrors.
Ma'am, also traffic mirrors.
Also,
Traffic mirrors.
Now let's move to lens. Who will summarize lens, spherical lenses? Lenses are not so in detail.
Can I?
Rohini? Aishwarya?
Yes, ma'am.
Advita?
Yes,
Wait,
ma'am.
Aishwarya,
Ma'am, can I
Advita,
say?
Adrit. Anyone?
Ma'am, so lens.
Wait.
Lens.
Okay, Aishwarya, tell me. Fine.
A lens are of like two types: concave lens or convex lens. Concave lens are known as diverging lens, and convex lens are known as converging lens. Concave lens.
Ashwara, wait. Adrit, if I give you two different types of lenses, how will you identify them by touching them?
Ma'am, the roughness,
Roughness?
ma'am, or the shape.
And can I tell?
Tell me more about the shape. Adrit, tell me more about its shape.
Ma'am, can I tell?
Okay, yes, Divesh.
Ma'am, can I say? Ma'am, like for the concave lenses, the edges are thicker and in the middle is thin. And for convex, the middle is thicker and the edges are thin.
Good. Great. Yes, please.
Ma'am?
Please continue. Who was telling the summary? Aishwarya or Ashwath or Charvi?
Yes, ma'am. So, concave convex lens are like used in cameras, magnifiers, and telescopes. Concave lens are used in glasses, spy holes, and convex are like thicker at edges and narrow in the middle, and concave are like thicker at the edges and narrow in the middle.
In lenses also, one of this is converging and other is diverging. Can you tell me which one?
Yes, ma'am. Convex is converging and concave is diverging.
Great. Yeah. Now, nature of image, not Aishwarya, but anyone else. Divesh or Sritij, you joined just now. Children, join on time and be for the whole time.
Ma'am, I was out, ma'am. That's why.
Okay. Sritij, we are, summarizing the light chapter. Now the topic is for spherical lenses. Can you tell the type of images obtained by concave and convex lens? Can you tell me the nature of image quickly? Charvik?
Ma'am, I have a doubt in the lens. Can I?
Yes, please, Rohini.
Ma'am, like the question is actually how do you identify the lenses, no? Like appearance is one of them, and can we also identify with the nature of image formed by the lens?
Yes, if we are not allowed to touch them, the type of image obtained is the only method to identify. To stand in front of the lenses, as you already know that the nature of lens is opposite with that of mirror. Like concave mirror is converging, so convex lens is converging. You can easily remember this, that the images obtained by convex lens will be same to that of concave mirror. Means because both are converging, right? So in the convex mirror, in most of the cases, image obtained will be smaller, means of varying sizes, real and inverted. But in the last case, when we keep our object close to the lens, we will see the image inside the lens only. Okay. Whereas in convex mirror, what we had that we had a wider view of images with a smaller sized images. Similar will be the case with concave lens.
Okay, ma'am. I have a doubt.
Ma'am,
doubts. Ma'am, first doubt is like, now what will happen if we keep one concave with one convex mirror, and we took one laser and in front of the laser, like the laser 4 lights, so in front of the 4 lights we keep one convex and then we keep one concave. Now how will the ray diagram look?
Very good question. Okay. You want to join two different lenses
At the
means
same light the same.
and the same single light is incident on them.
Yes, ma'am.
Okay. Can you think of it? And that's a good question. So I want everyone to just place mirror end to end or stick them, make a diagram in such a way. And can you once draw the diagram like how it will be, how the ray of light will bend, how it will refract?
Ma'am, I have one more doubt,
Hmm.
and the doubt is like my specs are also a kind of lens, right?
Hmm.
So what I did, I just wanted to test. So what I took a light object,
Hmm.
and then I kept my specs, like I kept my spectacles in the front of that in front of that light source, and then like then when I saw the light was clearly visible, and it was not like the light source was not bending or anything like that.
But how did you notice the bending of light?
I'm
How
like
did you
bending of
calculate?
light means how not bending, like when we take one I don't know which kind of specs, like specs I think concave mirror, convex mirror, concave convex lens, and when the light when the parallel rays converged in the beyond the focus and all, so like the light is will touch the focus right when it converges, but that I didn't saw any change in the light, so it was directly straight, it was parallel only, it didn't had any change. Why so?
Mhm. Because normally if we are sitting in the tube light CFL or LED in our room, the bending will not be visible because that is a large beam, not a single ray like that of laser light. So it's not easy to
Ma'am,
uh,
but I kept it in the dark room, like at night I went to a dark room, I closed everything my door, and then I put a torch, then it didn't happen, or torch or mobile light,
but
it didn't work.
torches are still uh,
I used mobile light also, ma'am, like
okay.
mobile light that's so small.
If you have the toy laser light, you can try with that once, but be careful that laser light do not enter your eye directly. Try it once, and for everyone else the task or the homework is that uh, try if you place the two convex lens, or if you do not have lens, think of it how the light will undergo refraction. Think it once. We'll discuss it tomorrow.
Ma'am,
Okay.
ma'am, since I joined it, what did we do?
Kshitij, we revised the whole chapter light and summarized every single topic again.
Okay.
Hmm. So children, listen, like for not for every chapter we are gonna do the same thing. It's better because I told you, I have observed that few of you hesitate to put a question to ask. If I'm telling you the chapter, you just raise your hand. After I stop sharing the screen, I look who all have raised their hands. I'll myself ask you the question, what doubt you have. And do not hesitate to share your views on any topic or anything. The more you speak, the more you come up, the more you will finish up yourself, you will nourish yourself. And that's why we are here, you and me together. So you need to help me to help you. Got it?
Okay, ma'am.
Hmm. Fine, we'll meet tomorrow in the next class meet, right? Bye bye. Thank you, everyone.
Okay, ma'am. Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Bye.